Hi viewers, welcome back to our channel Raveendra for Students. In this video, we are going to see important bits and questions for AWP midterm examination 2. Yes, for midterm examination 2, we will have Unit 3, Unit 4 and Unit 5. And again, we are having two parts in it. One is objective online mode and other one is descriptive in offline mode. So coming to objective, so we are having 10 important questions that are bits, and out of those 10, you may get 6 or 7. And similarly, from unit 4, out of 10 bits, you may get 6 or 7. And similarly, in unit 5 also, out of 10, you may get 6 or 7. Then coming to descriptive part, so there are 4 important questions. Out of those 4, you may get any 2, and again in this 2, you can answer only one. You can have either or type choice. And similarly, it is applicable to unit 4 and unit 5 also. Then coming to the first one, objective bit 1 in unit 3, that is aperture and lens antennas. Which antenna works with the Babinet's principle? So Babinet's principle is the operation for slot antennas. So slot antennas is the answer for it. Then second one, the radiation pattern of slot antennas is. The radiation pattern of slot antenna is, you know very well, it is omnidirectional or spherical radiation pattern. Then coming to the third one is flared out or opened out waveguide is a dash antenna. Yes, by opening the waveguide ends, you will get a horn antenna. So answer is horn antenna. Then coming to the fourth one, horn antennas are used in the frequency range of microwaves. So microwaves is the answer for this. Then coming to the fifth one. The fifth one is a single narrow beam of radiation results in square corner reflector for spacing of S equals to how much? So a single narrow beam. For a single narrow beam, there should be a separation or spacing of lambda by 2. If you want two narrow beams, 2 lambda by 2. That is lambda. So you know that formula very well. Then coming to the sixth one, the number of images formed for square corner reflector using method of images. Yes, square corner reflector, you know very well, there will be 3 images in addition to the primary element. So 3 is the answer. Then coming to the seventh one, for square corner reflector, the flaring angle should be 90 degrees. So 90 degrees is the opening angle or flaring angle in square corner reflector. And coming to the eighth one, which of the following antenna has the highest directivity? Yes, out of all practical antennas, we know very well the parabolic reflector or parabolic dish antenna will have the highest directivity. Then coming to the last but one in unit 3, that is aperture and lens antennas, the electrical path length is more. So electrical path length is more in which lens? So it is a delay lens. So since a delay is happened due to the more length, the answer is delay. Then last one in unit 3, lens antennas are used in the frequency range of, yes, lens antennas belongs to millimeter range. So millimeter waves is the right option here. Then coming to unit 4, yes, the first one in unit 4 is which antenna is a low profile antenna? Yes, answer is microstrip. All are low. Its directivity, its gain, its size, its weight, all are low. So that's why it is called a low profile antenna. Then coming to the second one, the most generally used shape for microstrip antennas, simply MSCS is. So most generally used shape is rectangular shape. You know it very well. So rectangular is the correct option. And the next one, the size of MSA is inversely proportional to. So it is inversely proportional to frequency. If the frequency is more, the size is less. If the frequency is less, the size will become more, inversely proportional with frequency. In the fourth one, the directivity of MSC is, one second, let me go back. Yes, the directivity of MSCS is, yes, 4. How do you get it? You know the general formula is 4 pi by beam A. Then you know the beam area of microstrip antennas is 1/4 of the sphere. That is hemispherical. Therefore, we'll get it as 4 pi by pi. So pi gets cancelled. You'll get 4 as the answer. The next one, fifth one, the suitable coordinate system for antenna measurements is. So what is the suitable coordinate system? For any antenna, we have to measure first radiation pattern. So for radiation pattern, which coordinate system is suitable? Spherical coordinate system. So answer is spherical coordinate system. Then the sixth one, comparison method of antenna measurement is also called as. So comparison method is also called as gain transfer method in antenna measurements. You know it well. Then coming to the next one, that is seventh one, Free's transmission formula is used in dash type of antenna measurements. So Free's transmission formula is used in absolute method of gain measurement. Absolute is the correct option. Then coming to the eighth one is the combination of phased array and DSP units is called dash antenna. So it is the combination of phased array and the DSP units. Therefore, it is smart antenna system. Then the last but one in unit 4, that is microstrip and antenna measurements, is the digital signal processing unit is used for dash in smart antenna system. Yes, this DSP unit we are using for the detection of direction of arrival. So direction of arrival, we will call it as DOA. So direction of arrival is the correct option. And the last one, which antenna can be used for tracking in radar? Yes, for tracking in radar, the best suited antenna is smart antenna, because we have to change the beam direction depending upon the target in radars. So therefore, smart antenna is used for tracking in radars. Then coming to unit 5, the first one is, which atmospheric layer has no effect on wave propagation? Yes, the layer in which the temperature changes are constant will have no effect on wave propagation. So what is that layer? Stratosphere. So in stratosphere, existing from 15 to 40 kilometers above the surface of the ground, the temperature changes are constant, therefore they have no effect on the wave propagation. Then coming to the second one, the line of sight. Just a minute. Yes, the line of sight distance is the distance traveled by the dash wave. Line of sight distance is the distance traveled by the direct wave. And the next one, Yes. F2 layer. Yes. Please wait. Yes. F2 layer of ionosphere exists between. Yes. We'll have the ionospheric layers. D layer from 40 to 90. Then E from 90 to 140. Then F1 from 140 to 250. Now what we want is F2. So F2 is 250 to 400 kilometers. 250 to 400 kilometers is the correct option, correct answer here. And the next one, the troposphere is extending up to a height of, so troposphere is extending from 10 to 15 kilometers, therefore it may extend up to 15 kilometers. So 15 kilometers is the correct option. The next one, for large distances, the Earth can be considered as a dash region. So for large distances, we have to consider the curvature of Earth also into account. Therefore, it will act as curved region. Next, sixth one, in general, the Earth will act as, yes, in general, it will have the capacitive nature, or it will have the leakage of capacitance. So leaky capacitor is the correct option. And seventh one, the process of reduction in signal strength due to variation in refractive index is called fading, or we can call it as faded signal. Faded signal is the correct option. Then the next one, the E layer of ionosphere exists between. D is from 40 to 90, then E is from 90 to 140. So 90 to 140 kilometers is the correct option for E layer. Then last but one, in fifth unit, that is the wave propagation is, for small distances, the earth can be considered as, for small distances, it will be flat. For large, it will be curved. For small distances, it will be flat. And last one, change of orientation of the vertically polarized ground wave at the surface of the earth is, yes, orientation will become change, vertically polarized wave will become horizontally polarized wave due to wave tilting. Answer is wave tilting. Then coming to a descriptive part, in unit 3, the descriptive part, we are having what is Babinet's principle and explain in detail about the slot antennas. Yes, we have to write this for 5 marks. So write neatly the Babinet's principle along with the slot antennas. Everything, its applications, advantages, everything please mention. And second one, draw various types of lens antennas and derive the design equations for the lens antennas. Yes, what are the various types? And for any type, we can derive the design equation. And third one, what are the feeding techniques available for parabolic reflector antennas, and explain briefly. So we'll have different feeding techniques. Out of those, which can be preferred and why it is preferred, you have to explain briefly. And last one, draw various types of horn antennas and derive the design equations for the horn antennas, similar to lens antennas. Okay, here you have to draw all the structures of horn antennas and you have to get the design equation. Then coming to unit 4, the 4 questions are, what are the most important characteristics of microstrip antennas, MSAs? Yes, we are having 10 points. You have to write all those 10 points for 5 marks. And second one, how gain can be measured using various methods. Yes, you have to write both comparison as well as absolute methods to get 5 marks for the gain measurement. Then what are the various sources of errors in antenna measurements? Here also we are having 10 points, so you have to write all the 10 points to get 5 marks. And the last one, explain the operation of smart antennas. So smart antennas operation, write in detail for 5 marks. Then coming to Unit 5, explain about the tropospheric wave propagation in detail for 5 marks. Then write short notes on sudden changes in ionospheric wave propagation, 5 marks. And define 5 definitions here. Critical frequency, maximum usable frequency, MUF, lowest usable frequency, LUF, skip distance, SD, virtual height, VH. Each definition for 1 mark, totally for 5 marks. And the last question, derive the origin of the Earth. By considering the radius of the Earth into consideration, you have to calculate the formula for D naught in terms of transmitting antenna and receiving antenna heights. You know it very well. Yes, that's it, students. All the best for your examination. Prepare well and get a very good marks. If anybody watching our channel first time, please subscribe to our channel and like our videos, and if possible share those videos to your friends also. And still, if you're having any doubts regarding the answers for the bits as well as the descriptive questions, please let me know in the form of comments section. That's it for today. Thank you all and see you in the next video. Thank you.